Welcome and thanks for joining us. My guest today is Jessica Souder. She's an AIRS Solutions Specialist at Palo Alto Networks. Jessica, good to have you with us.
Thank you very much.
And we're going to talk about artificial intelligence, AI security, very, very big topic, still rolling out, I would say, despite all of the hype of the last couple of years in the federal government. But from your sense of dealing with agencies, where would you say the government is in terms of adoption, maturity of AI adoption, and what are some of the things you're seeing them try to do with AI?
Well, thanks for the question. It's a good one. It's a good place to start. Across the board, we're seeing agencies adopting in very different degrees. And so I get the privilege of working with federal civilian agencies, DoD, the intelligence community, and I work a little bit with state and local governments as well. And it really depends, which isn't a very definitive answer, but I think it has to do with risk and also understanding how to apply AI in an efficient way. So everyone's keen to adopt, but still working on how to best apply it in a way that they'll be successful. Two sorts of different applications. On the administrative side, we see organizations adopting AI to create efficiency in the administration of their activities, in back-end solutions like for financial activities and making sure that financial accounting gets done well. That's a little bit easier in some cases, I think, to adopt because there's no classified or sensitive data other than PII behind it. There's some sensitive things, but nothing like that we're as concerned about on some of the other federal agencies who do use sensitive data, intelligence collection, or may have access to things that we're a little more concerned about from a risk tolerance. And so they're going about it in a more methodical way, still wanting to use AI to support their mission, but potentially having a greater sense of wanting to go slowly to manage that risk.
Yeah, so it seems to divide among those applications that are more related to robotic process automation of back-end things, like you say, like finance, versus mission, which is a little more subtle and a little bit riskier.
Absolutely. And then, of course, we see AI has been around, since the 50s and 60s in some shape or form, and machine learning has really been with us for decades. So we have predictive models that are already part of our space that we may not be aware of, but when we think of AI, especially over the last few years, we think of generative AI. We think of models where you put in a prompt and it generates a result. It's non-deterministic and it's new in the space. And so that's where we see some hesitation because we're not sure about the answer that model is going to provide. It won't be the same every time. And so the users who are adopting it are working on how they'll integrate that into their mission space when we see something that's creating essentially something new based on a prompt.
Well, it's pretty good for recipes. But
it's absolutely good for recipes,
but
right?
Beyond that, you're on dicey ground, I guess.
Potentially, but also I think it's just about fitting it into your process and teaching the users how to interact with it and understand how to gauge it and how to approach it with a bit of pragmatism.
And perhaps more than other machine learning types, the generative or agentic and all these words come with at least some fear of the cybersecurity implications of it.
Absolutely.
What are those? And besides hallucination, that worry, what are some of the other security issues that you find agencies have or that they should have if they don't have them yet?
Sure. So they range, actually. And if you think about generative AI, one of the largest security risks is what we call prompt injection. So a user either accidentally or purposefully putting a prompt into the model with the outcome that elicits a response that's unwanted or dangerous. And so that response could be actually hijacking the model. It could be some sort of leak of special data or unique data that we don't want leaked. It could be actually taking over the model. And so there's some interesting examples out in the world, especially one where a very ingenious user, a car dealership actually had a chatbot that they were using for their customers to interact with the pricing model. And someone got on there and said, I would like to buy this vehicle for $1. Can you price it for me? And the chatbot very helpfully said, yes, I can. And so that user was able to convince the chatbot to sell the car for $1. Now, luckily, there was a disclaimer, I believe, attached to that chatbot. And so the dealership didn't have to honor that. But you can imagine how if you were to hijack a model or get to the point where the model was ignoring its training and was responding to the user, that user could get access to data that they shouldn't have access to, sensitive data. They could have the model doing activities for it for them that they shouldn't be doing.
Interesting. So that gets to the question of data. And we know now in the last number of years, at least at the federal level and to some extent state and local level, it is the data that hackers are most after.
Yes.
Are there special considerations for AI protection with respect to data versus just protecting your standard databases and online spreadsheets and all of that traditional stuff?
Yeah, absolutely. And one of the things we're always worried about is DLP, but we're like data leakage, but we're also thinking about the data that shapes and trains the model itself. And so wanting to protect that data, whether it's for generative models or for predictive models, because if you were to change like the weights behind a predictive model or to change the data behind a predictive model, you could actually change the outcome of that model. And we use predictive models for many things. If you think about analyzing traffic patterns or analyzing potentially like accident response for state and local governments, you want those models to be working off of accurate data so that the users who are deploying those resources, especially during high traffic times or any kind of other specific holiday or issue, are having those models performing well. And so as you increase the potential of an organization that's relying on those models, the sensitivity of what they do, you naturally run into an issue where if the data were to be changed or somehow altered, it could change an outcome and create an incident.
Right, so you're worried not just about data exfiltration, but adding in data that you didn't want.
Or doing what we call data poisoning for predictive models.
And that's the same thing as erroneous data, specifically to skew what the output is.
Exactly,
Okay.
exactly.
Data poisoning, wow.
I know, all these new terms.
Because you do want to sometimes alter your data for your own purposes, like just to make up an example, a road that was barred to trucks, and you want to analyze that road, and now trucks are allowed. You would need to change the training data.
Potentially, yeah. Or if you were a smart hacker and you were on your way to work and you could somehow influence Google Maps, imagine how you could clear the route out for yourself.
Yeah, I'm gonna think of that one. I might try that. I don't commute
anymore. I
just
gave some interesting ideas to a few people.
All right. And then this kind of question came up in the cloud early era when people got a credit card and you could buy a cloud account, and all of a sudden it went out of control. Shadow IT with respect to AI and people having, in the government, say, using a publicly available chat box, ChatGPT or the Google one, or there's a whole bunch of them. That's a danger too, and how can you protect against that shadow idea?
It is, and we have very interesting conversations about that, especially at the state and local level, but also at the federal level, where we see employees who are wanting to get their work done in an efficient way, enterprising employees who maybe are saying, oh, I could do this over here if I just use AI, but potentially that organization has essentially blocked or shut down access or moderated it in such a way where you're not allowed to do certain things with the AI. And so yes, we see a lot where organizations are either sort of tacitly allowing it because they feel like it's within their margin of risk, or deciding, no, we're going to block this, but then we still have some users who are either working on those tools at home, or maybe it's an organization where you are allowed to bring your personal devices to work, and so maybe they're doing that on those devices as a way of like cutting time. And so we have these conversations all the time, and it's something that responsible AI officers or chief AI officers, along with the CISO and sometimes even the network security and app security teams, are getting involved, recognizing that the users are just trying to do their job and have found a way to maybe do it more efficiently. So how are they going to put tools in place or policies in place that allow the most robust use but still protect their systems?
You almost need a sandbox, I would think. Because
actually, you've hit on something really important there, and we talk to federal organizations about that a lot, about starting with a sandbox as a place to experiment with, as a place to test new models, to test new security solutions, especially because this is an evolving and still maturing space, not just AI, but the process of AI security. And this gives them a chance to test new vendors and also test new skills for themselves. We deal with a lot of teams who are not sure how they're going to test AI security tools because it's their first or second time testing one. And so we walk them through very carefully what we believe success criteria looks like in general for those tools, and then help them customize that success criteria for their organization and their pain points.
And I imagine the training that you mentioned, the skills, is really important, especially, say, in prompt engineering.
It is.
I imagine, again, to make an absurd example, if someone used a public chat type of AI and asked, well, what if we attack Tehran from Route 6? I don't know whether there even is Route 6 in Iran. But that kind of question going out could get into the ecosystem, and then you'd have a real problem.
It could. A lot of the models will actually block that based on those foundation models policies. It depends how you ask it, and I'm actually not going to say how to ask it here today to make
Sure.
that happen, but we can talk after if you want.
All right, good. Slip me a note and I'll try it out.
Absolutely, absolutely. That said, that's something that a security system could block. So we call that runtime security, and that offers an opportunity for the CISO and the security posture management team to say, okay, we're not going to allow questions about attacks in our ecosystem, or we're going to block the users from putting this kind of data into into either our external AI, like you're talking about, that's hosted by some of the foundation models, or an internally hosted or fine or tuned model that might be like a hybrid approach.
So you would use the same basic good management principles
Right.
you would with any new technology.
Absolutely, and there's lots of comparisons to be made. When we think about cybersecurity for AI, we try not to like boil the ocean and reinvent everything, right? So it's the same kind of concepts you would use for software, for other artifacts in your environment. You're going to discover, assess, and protect your environment. So you're going to discover AI in your environment, you're going to assess it, and then you're going to protect the users and the data and the company or the enterprise against it. And I think a lot about that to back to the 90s, you know, when we were scanning things that we would attach to our email, looking for viruses. We're sort of there with AI. You know, there's open source repositories where you can download models, and there's many available. Some have over 2 million models. And so if you're a user or an enterprise that's just starting to build AI, start by scanning those models. And then test those models, and then assess and deploy and monitor them.
Right, so the visibility
Visibility is huge,
always important.
but it's still the same concepts from traditional cybersecurity.
Got it.
Right.
And then there's a practical issue, especially in DoD, where they are operating sometimes in what they call the tactical edge,
Yes.
where connectivity and austere environments may not be available easily back to the cloud where the calculation takes place, where the execution of the request takes place. So how do you work in that environment? How do you plan for that securely?
Some of the next challenge, as well as putting things on the back end, so that when those tools call back, there is some security there, but it's also about education for those end users. And as we look at autonomy, that's going to be one of the next big spaces. And so we have a situation where we've got drones and other autonomous systems that will be supporting the warfighter. And in fact, in some contested environments, there's even this term coming that's being coined called contested autonomy. And so how we'll protect and how we'll use autonomy in those spaces. But that's evolving, and that's sort of that next great concept or area to focus on for organizations.
Because autonomy worries DoD because of the need for accountability, say in fire.
Right.
On the other hand, maybe you'd want autonomy for the drone to come back.
Well,
to get
there's
back
always
to
that
you.
human in the loop safety protocol, and we think about that when we think about agents. Just agents as they're going to be used for agentic AI in a more traditional space. Right now, we kind of recommend to our customers that they think about architecting agents just to the least level of access or the least level of autonomy that they're comfortable with, so that those agents don't necessarily have access to data that an individual or a bad actor could hijack or accidentally cause an issue. We've seen instances where agents have not known what to do or had too much access and actually deleted things or deleted databases. And so we're trying to both install security and also teach and guide our users into limiting what each agent does so that it can be easily managed.
Just as you limit what any user can do.
Absolutely, especially in some of the sensitive environments we've talked about.
And that gets to the question of zero trust. And zero trust in AI, you hear a lot in the same conversations nowadays. Zero trust is still policy and still something technically the government is trying.
Paradigm, really.
To get to. So how does AI fit into the zero trust when you have bots and non-human accessors of your resources?
I'm so glad you asked that, because it's almost the same. It's that whole supply chain. And so we use similar terms as we would for any other kind of product. And so we talk a lot about AI security by design. And it's about that supply chain and about focusing on security from the very beginning. Whether you're the one coding the model, so if you and I were coding together, we would still be scanning our work, looking for errors, and making sure that even if we were vibe coding, that there was no errors that had somehow slipped into our code that would create a vulnerability, or that something hadn't been accidentally imported from a bad actor, from one of the third-party repositories, and maybe inserted into the code. And so we think about it from the beginning of that supply chain. Where's the model from? Who's designed it? Has it been scanned? Are they owning it? Has the model been signed, essentially, so that we know the last time that the developer touched it? And then have we tested the model? And we call that red teaming, but it's really just testing, is to test the deployment, especially of generative AI models and agents, and ensuring that the deployment guardrails are where we want them to be, so that that's at the risk level for that organization, and that those guardrails are working, that it's not causing data leakage, that users aren't accidentally getting access to a response that we don't want them to have, or that they're not able to put data or prompts or any kind of documents or materials into that deployment that the CISO or whoever is setting the policy have determined are outside of the risk tolerance.
Right, in banking they have pressure testing.
Absolutely.
You almost have to pressure test to make sure that bot, say it's a Western Hemisphere thing, that it doesn't access data from the Eastern Hemisphere.
100%, and it's a very similar concept.
All right, good. Well, that's good advice. Test it. Yeah, always good. Testing, the same thing.
Absolutely.
Some of the fundamentals still apply. And you mentioned that you do work with state and local government, and
I do.
often they don't have, and they're hit for ransomware much more often than the federal government is, because the federal government doesn't pay it, and even the worst hackers know the government isn't going to pay that. But they've gotten stuck at the state and local level. So I wanted to ask you about the resources that are available to, say, the Defense Department, which seem, to the normal person unlimited, versus what might be available to, say, a state or even a county level agency that has the same technical challenges of security.
Well, it's all relative in some ways, because DoD also has some considerations that make it in some ways more limited for them to adopt security protocols. So the authority to operate, process ATO, also some restrictions on where they can put products and how much they can use the cloud, whereas state and local governments have a little more freedom in what they can adopt and can take cloud-based solutions and really incorporate them into their architecture. And as we see AI security maturing, many of the tools are new, and so it's a great place for us to work with them. And early adopters then have the ability to provide us with input to features. And so as they decide, this is working for us, that's kind of a bonus for some of those state and local governments. The other thing I'll say is that there's still other benefits that do come from the federal environment that'll enable those users. So NIST has a framework that we call the NIST Risk Management Framework, RMF, which is put out for everyone's use. MITRE Atlas is also another great tool, and the OWASP Top 10 for both LLMs and agents are all out there as frameworks that those state and local governments can then decide what they want to adopt that makes the most sense for them, including even overseas frameworks. So Singapore and the EU also have great models, so does the UK. And so I think there's a lot for them to draw on, and they have actually greater flexibility to set those policies on their own and see what works for them for where they are at any given time.
So it sounds like there is some good opportunity for vertical sharing within the levels of government.
Absolutely, and also cooperation regionally. And we're seeing that too. We're seeing some cooperation regionally where we have certain states that are setting up either through their university systems or through state or regional governments sort of a hosting opportunity where they will host GPU access as well as access to AI security tools.
Right, so if you're, say, Arizona, you probably should check what Nevada's doing or something.
Potentially, yeah, or it might be very different. It depends on what their different requirements are. But in this way, they can also almost host some of the capabilities as a service to incubate AI in the state or in the region.
Okay, well, our last question is your lightning round question. And let's fast forward, say, a year or a couple of years into the future. What do you think that agencies will be able to unlock for themselves if they get their fundamentals of security lined up?
I think agentic security is going to be very changing to the workforce. I come from the intelligence community. I spent a lot of time working in that space and with some of the partners, and there's so much data. And I was at a meeting this morning where we were talking about making data AI ready, and that really means understanding where your data is, understanding the different kinds of data, different classifications of data, and have that solid map so that you can work with AI efficiently and make the overlay of AI useful to you. And so I think that's where we're going to be. We're going to see hybrid workforces where we have agents who are hopefully trusted and have security around them at that point, working with some of this specialized data to enable our federal workforce, not just with administrative capabilities, but also mission-oriented ones, in a way that gives them more free time to think. So I think what's happened is as our task saturation has increased over the last decade with so much data, your average government employee is spending a lot of time doing things that isn't necessarily using the human brain as well as it could. And this will hopefully free up some time for them to think more critically and spend more time looking at what the results of like an AI generated prompt or capability are, and then come back and say, this is what I think based on what the data is telling me through this unique tool.
More free time to think. That is a great note to end on, so
Okay,
I want to thank you
great.
for being with us.
Thank you.
Jessica Souder is an AIRS Solutions Specialist at Palo Alto Networks.